Well, hi, good morning. Thank you for joining me here in my shop for another run at this radio. Today is February 10th. Yesterday it got up to something like 12 degrees here when it should be -5. Today it's going to be warm again. Just the strangest winter we have had here. Okay, so interesting result. At the end of the last video, I found the radio was operating on the broadcast band for the first time and operating well. What happened? Was it one of these capacitors I changed? I just don't think so, because the radio had worked on shortwave. It may be weak, but it had worked. So I think, after thinking about it, I think it was cleaning the switch that brought the AM band back to life, and then I just didn't test it or notice it at the time. So that's what I'm going to attribute it to. I just can't imagine how any of these capacitors could have somehow brought that band back to life. So there's two more capacitors down in here, one here, one here. This one I think I've already looked at as to what it's doing. So let's try to figure out what this one is and remind ourselves what this one is. We'll change them and see what's happening here. So I can see, first of all, this capacitor, the one terminal is going to a ground, one lead is going to a grounded terminal here. The other lead is on pin number what? I would say it's pin number 2 on this tube, on the detector tube. Pin 2 on the detector tube. I think now, because I don't think the schematic shows pin numbers. The detector tube was what? A 7B6? Was that what it was? 7C5? 7B6? 7B6. There's the diodes. Number 2 is the plate. The plate on the detector tube has a capacitor going to ground. Does it really? Did I get it right? Let's take a look at the schematic here. Okay, detector tube. These are numbered. Pin number 2. And there's no capacitor going to ground. Okay, so I boobed that up somehow. How about pin number 2 on another tube? Here's another pin number 2, but no, right into there. What about pin number 2 on the output tube? Did I make that mistake? There's one. Did I make that mistake? Maybe I did. You know what? I think I did. Yep. Nope. Yep. Yes, I did. It's the output tube. So this is the guy we're talking about. Now, what is the purpose of this capacitor? He's on the plate of the output tube. His job is to quash any RF signals that are left here, if there are any, and most importantly, to quash any harmonics, high harmonics that are coming out of this tube arrangement or circuitry here. Apparently there's a lot of harmonics in these tubes. So that's its purpose. So if you took it away, probably the tone would go up, the pitch would go up. I think in the radio you'd hear a difference, and you'd have harmonic signals going through here. And what harm is that? I don't know if it's terribly harmful. It's a waste, I guess. Okay, so that's that one. Now the other one was which one? Was this one? Wasn't it this one? I figured it out to be, because it's hooked up to a long wire that goes up to the switch, and the other end of it has on a terminal with leads, and there's a resistor there. It looks like a 47 something. A 47 something. So it could be anywhere on this piece of wire here. There we. Oh, it's inside. It's inside. It's supposed to be inside. How did I manage that? I've worked a miracle here. Well, I'm not going to sweat over it. I'm pretty sure it's this capacitor. Let's cut them out and see what's up. Cut them out of there. Oh, I've taken my cutters somewhere. So we want to do this guy. Be hard to preserve some lead here, but I'm going to try. And then down here, let me just, once again, now it said 0.02 on the, 200 volt. Can I see through this black with a magnifier? You can actually see a little bit through the black junk here. Not enough though. This is kind of weird what it's doing here. It's kind of polishing it. Supposed to be scraping it off. This may not work out here. Oh, I'm gonna poke my eye out. 0.2. No. 0.2. That's pretty clearly. Yeah, that's a big one. Wow, it's a little bigger than I thought. 0.2. There were 2 0.2s, weren't there? There was the point. Okay. 0.2. 200 volt. Okay, I have to find a 0.2. Wait a second, let's look at that schematic again. 0.02. I'm looking at the wrong capacitor here. 0.2, 0.2, where it is? Over here. This is the one here. Wasn't it? No, that's that other one. Oh, I'm all confused. Who cares? I'm going to change that capacitor and we'll carry on. Okay, got one new one installed there. And this is the other one I just took out of here. And again, it's just so blackened. Wow. Let's put these guys to the test, even if I can't read their values. Pretty sure I got it straight on the schematic. Okay, 50 volts. What do you say there, capacitor? Oh, popped right open. 150. 250. Well, this guy's testing really good. Okay, good for you. See, it actually looks, you know, other than being black, it looks, you know, like it hasn't been roughed up in the ends, or maybe the hermetic seal is still good. That's what the wax is for. The wax is to stop moisture. Because in a hot radio, the wax gets soft. It starts to flow right off, and then you just have moisture penetration straight through. It's just cardboard under there. It's not going to stop moisture. Okay, here we go. How about this guy? Well, he's the opposite. He's a sick puppy. Exact opposite. Good show. Okay. We're 1 for 2, I guess you would say. Still worth changing out the wax, old wax capacitor. Even if it tests fairly good, how much more life can it have in it compared to what I'm putting in here? These are 100-year capacitors. I'm sure these will be good 100 years from now. Okay, I'll put in the next capacitor and then we're going to test the radio and make sure it's still working. Okay, I think it's time to test this radio and see how we've done with it. Let's just check a couple things. Okay. Switch is on. Volume up a bit. And I've already switched on the antenna. I don't have to go running to do that. There's that terrible interference that I suffer from at my house still. Broadcast band. That's terrible. Hey, listen to that. Wow. You can hear stations in behind it. Well, the radio's working, and if that interference wasn't there, I think we'd be just as impressed as yesterday. And I have hunted many times to try to figure out what this ticking is that goes on, and I've been unsuccessful every time. Okay. I think that's it for today. And tomorrow, so that basically ends the audio side of the radio, although some of these capacitors are related to more general things throughout the radio. Now what's left in terms of wax capacitors? I see one here. Wow, not very much. There's one, it's kind of, no, that's not wax. Well, there's only one more to go. Now we'll do that tomorrow, and then it's a question of beginning to check things like the alignment, the sensitivity, pin voltages on tubes and stuff like that, and just keep going. Very good. Okay, well, thanks a lot for watching, and I'm off to enjoy my day. See ya.